So this is the emissivity measurement apparatus, and here emissivity means first we should know what is emissive power. It is the radiant energy per unit time per unit area. If we are having a surface, the energy radiated per unit time per unit area is called as the emissive power, and it is notated by capital E. And emissive power of the black plate it is notated by EB. So the ratio of E by EB it is called emissivity, E by EB. So for a black plate the emissivity is 1. Now here in this apparatus we are having a test plate. This is the test plate and this is the black plate, and we are going to find the emissivity of this test plate, and the temperature of this test plate is called T1. Test plate is called T2. Temperature of the black plate is called T1. Now, so these are kept at a airtight fashion, and now we are coming here. So first, this is the main switch. So we have switched on that. So this is again we have to switch on this too. We have to switch on that. Now here there are two knobs, and these knobs represent this ampere and ammeter and voltmeter. If these two knobs are kept upwards, that means now it is set for test plate. The dials are set for test plate. Now first what we want to do is we are keeping these two knobs downwards. Now this is set for the black plate, and then now we are adjusting this particular. This is the heater control. Heater control controls the heat which is applied or current which is applied to black plate. So we adjust it, and we are making that as 80. So here look, this switch is towards this 100 volt. That means here by looking at the voltmeter there are two dials, 0 to 100 and 0 to 200. So if switch is closed towards 100 volt, we should take the dial which indicates from 0 to 100. Then so now we have applied this one and the voltage is set at 80. Now we are putting these two knobs in the upward direction. So in the upward direction, this is actually for test plate, and test plate voltage should be less than that of black plate. So black plate we have kept at 80. So we will be keeping at some 60 or so. Let us say we are keeping at some 60. Now, so everything is set now. Now we should go for reading. So for reading, so we are having the test plate here. So in the test plate we are having the current. Current is shown as say 0.5. 0.5, say current is 0.3. So voltage is say it is about some. Let's take that it is some 65 or so. And now we are going to look at the temperature. So while looking at the temperature, T2 is of test plate. So we will adjust this knob towards 2, and now we are getting T2. So this reading is this is actually 3.8 into 10 degree, that is 38. So we are having T2 as 38 degrees Celsius, and T1 we have to adjust this now. Now we are having T1. T1 is about some, it's 45, 45. So T1 is 45. Again we have to get V1 and I1. V1 and I1, for that this should be moved downward. Now we are having this V1 is 80, I1 is 0.75. So we are having those readings. Now we should get the ambient temperature, that is T3. So T3 it is about some, it is 38. So what we do is after every 10 minutes we will be taking this T1 and T2. So each time we will be noting T1, T2, and at last at one point, so here let us take T2 is say 39, it is say 44, something like that. At last at one point these two temperatures will be same, that is say this is 43 and this is 43. So at that particular point we can stop the experiment. That means even though time continues, the temperature will be same. So at that particular point we will be stopping the experiment. Now we are having 43 both sides T1 and T2 are 43. That is the surface temperature Ts, and this is the ambient temperature, and we can call that as Td. So here look, W1 means it is the V1 into I1. So V1 we have already obtained V1 and I1, that is both are representing voltage and current for the black plate, and W2 is V2 into I2. So again for test plate, so we are having W1 and W2, that is equal to epsilon B minus epsilon into sigma into A into Ts raised to 4 minus Td raised to 4. This A is area of the test plate, and that can be obtained from the specification. And also Ts, Td, etc. Ts surface temperature is obtained, Td is the ambient temperature, and Eb, epsilon B is the it is 1. Emissivity of the black plate is 1. So by using the given values and Ts, Td, which are obtained by this experiment, we can calculate this epsilon or the emissivity. That's how we are finding the emissivity of the given plate by using emissivity measurement apparatus. Thank you.